Hello friends, Rahul Jha welcomes you. Today we are going to talk on topic how much pollution is created by using different methods of producing renewable energy. So first we'll take wind energy. So let's start. How much pollution is created when a 3 megawatt wind turbine is manufactured? Environmental impact of manufacturing 3 megawatt wind turbine can be significant in terms of energy use, raw materials and associated emissions. Although it is much lower than that of fossil fuel based energy systems over the turbine's lifespan. Here is a breakdown. Key components: steel used for the tower and other parts, fiberglass or carbon fiber for the blades, copper for wiring and electrical components, concrete for the base, rare earth material or rare earth metal if the turbine uses permanent magnet generators. Manufacturing impact. The pollution of greenhouse gas emissions come primarily from mining and processing of raw materials. Steel and concrete production releases CO2, especially due to cement manufacturing. Rare earth metal mining can produce significant waste and pollution. Transportation, moving heavy components to and from manufacturing sites. Energy use. Factories typically rely on energy which may come from fossil fuels. Life cycle assessment, LCA studies. Manufacturing a typical 3 megawatt wind turbine results in 700 to 1200 metric tons of CO2 equivalent emissions. Tower. 60 to 70% of emissions due to steel production, blade, 10 to 20% emission, foundation, concrete production is responsible for 20 to 30%. Offsetting emissions. A wind turbine offsets its manufacturing emissions within 6 months to 1 year of operation depending on wind conditions and energy output. Over its 20 to 25 years lifespan, a 3 megawatt turbine produces 50 to 100 times more energy than it uses in its entire life cycle, including manufacturing, installation, maintenance and decommissioning. While the initial manufacturing process does create pollution, wind turbines significantly reduce greenhouse gas emissions over time, making them one of the most sustainable energy solutions available. In producing 1 megawatt of energy, how much total pollution is produced in tons? The total pollution produced per megawatt of energy depends on energy source and includes greenhouse gas, that is GHG, emissions and other pollutants. Here's breakdown for different sources of energy, focusing on CO2 equivalent emissions, CO2e, which account for global warming potential of all greenhouse gases. Fossil fuels, coal, pollution per megawatt hour 820 kg carbon dioxide emission per megawatt hour. Pollution per megawatt hour 820 tons CO2 emissions per year, assuming constant operation for 1 year or 8760 hours. Other pollutants: sulfur dioxide, nitrogen oxide, particulate matter and heavy metals, mercury. By natural gas, pollution per megawatt 490 kg CO2 emission per megawatt hour. Pollution per megawatt 490 tons CO2 emission per year. Other pollutants: lower SO2 and particulate emissions than coal but still emit NO2. Renewable energy. Wind energy. Pollution per megawatt hour 5 to 10 kilogram CO2 per megawatt hour life cycle emissions including manufacturing, transportation and installation. Pollution per megawatt 5 to 10 tons carbon dioxide emissions per year. Pollutants minimal, mostly from initial manufacturing. Solar photovoltaic cell. Pollution per megawatt hour 20 to 60 kg CO2 emission per megawatt hour. Pollution per megawatt is equal to 20 to 60 tons CO2 emissions per year. Pollutants minimal, primarily from manufacturing. Hydropower. Pollution per megawatt hour 4 to 10 kg CO2 emissions per megawatt hour. Pollution per megawatt is 4 to 10 tons carbon dioxide emission per year. Other pollutants, some methane, CH4 emissions from decaying vegetation in reservoir. Nuclear. Pollution per megawatt hour 12 kg CO2 emission per megawatt hour. Pollution per megawatt 12 tons CO2 emission per year. Other pollutants, very low direct emissions. Waste is radioactive but not air polluting. Comparison chart. Energy source pollution per megawatt hour kilogram carbon dioxide emission. Pollution per megawatt per year in tons carbon dioxide emission. Coal 820 kilogram carbon dioxide emission and per megawatt per year is 820 tons. For others also figure is given like natural gas 490, wind 5 to 10, solar 20 to 60, hydro 4 to 10 and nuclear 12. Key takeaways. Fossil fuel like coal and natural gas produce hundreds of tons of CO2 emission per megawatt annually. Renewables like wind and solar produce single-digit tons of CO2 emission per megawatt annually due to life cycle emissions, making them far cleaner in comparisons. Can wind energy be produced in places like Delhi successfully? Producing wind energy in places like Delhi presents challenges due to following factors. Key consideration: wind speed. Wind turbines require a consistent average wind speed of 6 to 8 meters per second to operate efficiently. Delhi's wind speed are typically much lower, averaging around 3 to 5 meters per second, which is below the threshold for most utility scale wind turbines. Land availability. Wind farms require large open space with minimal obstruction. Delhi is a densely populated urban area with limited open land, making large-scale wind farms impractical. Air quality and maintenance. Delhi's high level of air pollution and particulate matter can impact the operation and maintenance of wind turbines by increasing wear and tear on mechanical parts. Regulations and urban constraints. Strict zoning laws, noise concerns and safety regulations in urban areas can limit wind turbine installation. Alternatives and possibilities. Small-scale urban wind turbines. Small vertical axis wind turbines, VAWTs, can operate in lower wind speeds and are better suited for urban areas. These can be installed on rooftops or within buildings, but their power output is limited. Hybrid renewable system. Combining wind energy with solar panels could be an effective solution. Delhi receives ample sunlight, making solar energy a more viable option. Hybrid systems can maximize energy production and balance intermittent wind energy generation. Offshore wind. Offshore wind farms are not feasible in Delhi as it is landlocked. However, supporting offshore and wind projects in coastal regions could contribute to the national grid. Nearby region. Northern regions like near Delhi like Rajasthan and Gujarat have higher wind potential and could produce wind energy to supply the national grid, indirectly benefiting Delhi. Conclusion. While larger scale wind energy production in Delhi is not viable due to low wind speeds and urban constraints, small scale solutions like rooftop wind turbines or hybrid system may be explored. Solar energy remains a more practical renewable energy options for the region. So this was all about pollution caused by renewable energy. If you have seen our channel for the first time, please like and subscribe our channel. Thank you.